Hi everybody! You are staring at my table right now because I want to show you these puzzles that we're going to be dealing with today. So when you get the sheet, it's going to look something like this. If you can print it out, that would probably be easiest. If you can't print it out, just lay another sheet of paper on top of it and then trace around these shapes. And then what you're going to want to do is cut the shapes out. So you can see that I have cut out oxygen and sodium so far. All right, so this is what we're going to use for our little activity today. The other thing you need, other than these puzzle pieces, is you need to take a look at the Ionic Bonding practice sheet that's on Classroom, because that's how you're going to be directed to use these little puzzle pieces. So we're going to use the example off of the first row that uses oxygen and sodium. Okay, so here you can see my puzzle pieces for oxygen and sodium. Now, if we take a minute and we go back to looking at the puzzle pieces as a whole, you're going to notice something about these puzzle pieces. Notice that, first of all, they're all representative, right? I don't know if that light is helping or hurting. I think it's hurting. Okay. So all of them are monatomic ions. Mono means one, and then monatomic means one atomed. So all of these are ions that are made out of one atom. So we're going to deal with these today, and then tomorrow we're going to deal with the polyatomic ones. Okay, so for the monatomic ions, notice you're given a couple that are anions and a couple that are cations. So the anion ones are all negative. Fluorine, chlorine, sulfur, oxygen. All of these are anions. And notice that all the anions have something in common. What do all of the anions have in common? They all have these little arrows that go in. That's what they have in common. And so that is used to represent that they are going to take electrons. The electron flow is in the direction of the arrow. They're going to take electrons on because of their high electronegativity. Now, in a similar way, look at all the cations. You have calcium, we have aluminum, we have potassium. All of these are cations. They're going to end up being positive. So what do they all have in common? Well, they all have these arrows that are pointing out. And that is to signify that all of these give off electrons. So calcium is going to give electrons. Again, we're following the flow of the arrows. The electron flow is going to follow the arrows. So cations are going to give off electrons. All right, so with that in mind, what you're going to do is look at that Ionic Bonding Practice worksheet, and you're going to find the two atoms that they indicate, the two ions. So in the first one, the first example that's written out there for you is going to be the oxygen and the sodium. Now I've cut out one of each. Here's an oxygen and a sodium, and with the puzzles, they're going to show you how these things actually form. The O is going to indicate one oxygen ion. The one puzzle piece for sodium is going to indicate the one sodium ion. Now, the thing that has to happen with these puzzles is they have to fit together. So notice that the positive end fits into the negative end because one gives an electron and one takes an electron, just like what happens in an ionic bond. But notice the sodium and oxygen come together, and there's still a spot for oxygen. Oxygen is not happy yet. It's not satisfied yet. And so in order for oxygen to be satisfied, you actually need an additional sodium. And so this is what you're going to do with the puzzle pieces, is you're going to fit them together until all the electrons present to be given have been given. All the electrons that need to be taken have been taken. Sometimes you're going to use all of the puzzle pieces for that group. Sometimes you won't. But what we're asking you to do is use only the ones indicated. So for sodium and oxygen, you can't pair an oxygen with a sodium and a chlorine, for example. If you have an open spot, you have to fill it with a second sodium. Now, this indicates how that compound is going to form also. We're going to have sodium. I'm trying to write upside down right now. There we go. There's sodium. And I'm going to use 2. So remember that subscripts like this 2 are going to indicate how many of each I'm going to use. Since I'm using 2 puzzle pieces for sodium, I need 2 sodium ions. I need a 2 there. And then for oxygen, I only need 1. So you can put a little subscript 1 here, or you can leave it a blank because blank means you need 1. Now, sometimes you're going to use all of them. Sometimes you won't. What you need to make sure of is that all the electrons available to be given have a place to be given to. All the electrons that are needed have a source that they can draw those electrons from. Sometimes you're going to use 1 of each. Sometimes it'll be 2 and 1. Sometimes you might use 3 and need a bunch from the other one. So just keep adding puzzle pieces together until all the electrons that are available to be given have been given. All the electrons that need to be taken have been taken. After that's done, you should notice that the charges, when you add them up and consider how many of each charges you have, that should be equal to 0, since ionic compounds are neutral. Okay, so that's how you're going to work with these puzzle pieces. Take out your puzzle pieces, arrange the compound, write the formula for the compound, double check that the math checks out. In the end, make sure you snap a couple pictures of your puzzle pieces. You can submit those also. And then you're going to submit this ionic bonding practice worksheet filled out. You can either print the sheet and fill it out, or you can copy the chart down on a separate sheet of paper and fill it out that way. You're going to submit that as well. Like I said, today we're only doing the front, and then in the next video, I'll show you how to flip it over and do the same thing with polyatomic ions. All right, see you later.